So today we're learning about the chain rule. It can also be called the outside-inside rule because of the way you think about it. So we're basically saying you're finding the derivative of a composite function. So if it's y of f of p of x, you'll find the derivative of this by taking the derivative of the outside but you keep the inside the same. Times the derivative of the inside. So the way this would work out is y1 would equal f1 of g of x times the derivative of g of x. And so it makes more sense when you use an example. So here we go. Our first example is pretty simple, kind of. So we have example 1. So f of x equals cosine square of cosine x, but with the 3 there. So the first thing with this one you do is you're going to get rid of that 3. So you make it cosine of x to the 1/3 equals f of x. Then you can take the derivative. And so we will do that by, I think another useful way to think of the chain rule is to make the thing in the parentheses a u. So you know that what you do is, and then the exponent is an n. So it's the same as n multiplied times u to the n minus 1 multiplied times the derivative of u. So there you get the outside times with keeping the inside the same, or whatever. Sorry. F1 of x. So you do that, this would make this 1/3 multiplied times cosine of x to the negative 2/3 multiplied times the derivative of cosine of x, which is negative sine of x. So then this, you'll have to simplify it. So you'll take the cosine of x and you're going to put it back on the bottom of the function, the denominator. So it's going to be 3 cosine of x squared and then a negative sine of x on the top. So that is your final answer using the chain rule. Example number 2 is a little more complicated, but not really. It is, though. So this is example 2. F of x equals x to the 3rd plus 3 squared. So this, if we use that same n minus 1 multiplied times d over d of x of u. If the x to the 3rd plus 3 is u, well, first we would take the 2 multiplied by the coefficient, and that is n. U is the inside part, so it's x to the 3rd plus 3 to the 1st, which is 2 minus 1. And the derivative of u is, so the derivative of x to the 3rd is 3x squared. And the derivative of 3 is 0 because it's a constant. So then we simplify it to be this. 2 times x to the 3rd plus 3 times 3x squared. So then it becomes 6x squared multiplied times x to the 3rd plus 3. And you can leave it like this, or you can simplify it one more step. If you simplify it one more step, it will be 6x to the 5th plus 18x squared. And so that's just the way you use the chain rule. And the chain rule is also cool because you can combine it with other rules for finding derivatives. Like, it can be combined with the quotient or the product rule. So, to help you solve more complicated derivative problems, and then you can combine chain rule with quotient or product rules, as it's relevant. You don't always have to do it, but sometimes it's relevant or necessary. And more often you'll have to do this part first, the quotient or product rule part. And that is the chain rule. I hope you all enjoyed watching. The end.